Okay, so my problem is number 6, and it is proved that A for all that makes an isosceles triangle, or is an isosceles triangle when you graph the points. So first, what you're going to have to do is you're going to have to do the distance formula to figure this out, so you can figure out the length of all the sides and decide whether it is an isosceles or not. So what you have to do first is do distance for all the sides. So first we're going to start off with AB. So here's A, and we know that A is 4 and -1. So when you have that, and then you have B, and you know that B is 5, 6 on the coordinate plane. So now you come across and do the distance formula, which is distance equals, oh, I have room, and then do the square root, and the formula is x2 minus x1 squared. I don't have room. And y2 minus y1 squared. So say this is in the same line. Sorry, y2 minus y1 squared. Okay, so that's the formula right there. That's just the formula that we're going to use. Now down here we're going to actually solve the problem. Well, the first problem. So once again, distance equals the square root of, so we know that 4 would be x2, so 4 minus 5 would be x1, and then squared, plus y2 would be -1, so -1, and y1 would be 6, so minus, oops, I did that wrong, minus 6, sorry, not and 6. Minus 6, okay, squared, don't forget the little squared up there. Then, so obviously we can see another coordinate plane here, that this is going to be -1, so 4 minus 5 squared is going to be -1 squared, so -1 squared plus, over here it's going to be -7 squared because you have two negatives, so you add and keep the sign, so -7 squared. And then down here, one more little thing, which would be 1, obviously, because 2 1s, 1 times 1 is 1, so 1 plus 49, and that will equal 50. Let me just keep it on the same line. Okay, that would equal the square root of 50. So that's for the first one. Okay, so now that we've done the side AB, we now have to do the side BC. So first, let's start with the B, and let's see what the coordinates are, and the C, and see what the coordinates are. So for B, the coordinates are 5 and 6, and for C, the coordinates are 1 and 3. So with that, you have to remember the distance formula, and remember that you're doing, I'll do it up here, you're doing distance equals the square root of x2 minus x1 squared plus y2 minus y1. I tried to really squeeze that in there. Squared, that's a 2 up there. Okay, so now that you have the distance formula up there ready and you can see it, let's go start plugging these numbers in. So distance equals the square root of, and the x2 in this case would be 5, minus the x1 would be 1, squared, plus, and the y2 in this case would be 6, and the y1 would be 3, squared. So once you have that, make another little square root. And here, 5 minus 1 is 4, so 4 squared plus 3 squared. Okay, once you have that, come down here. 4 times 4 is 16, so 16 squared plus, not squared, sorry, plus 9. Sorry, that's not squared anymore, obviously, we just squared it. Okay, so 16 plus 9. And 16 plus 9, I actually didn't need those parentheses either, but whatever, my bad. 16 plus 9 is the square root of 25. And that's it for the side BC. Alright, for the last step, we have to do the side AC, so that's like closing up the whole triangle. So, of course, but like before, we're going to start with the coordinates of A and the coordinates of C. And the coordinates of A are 4 and negative 1, and the coordinates of C are 1 and 3. And, of course, start with distance formula up top so you can reference it. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. I'd really be squeezing that one in. Okay, so like always, now you have your distance formula up there to reference. So now let's set up the problem with the numbers plugged in. So distance equals the square root of, and the x2 in this case would be 4, minus the x1 would be 1, negative 1 actually, squared, plus the y2 in this case would be negative 1, and the y1 in this case would be, why do I keep doing that? I'm sorry, it's not a coordinate, Alexis, hello. So, minus 3 squared. And now once you have that, it is 4 minus 1 is 3 squared plus negative 1 minus 3 is, what? Oh, okay. Same sense, add and keep, so that's negative 4 squared. Sorry, I didn't write that part down, so it kind of confused me. Okay, so now the square root is 9 plus 16, and that will give you the square root of 25 also. So if you recall, A and B, the side AB equal to a square root of 50. The side BC equal to a square root of 25. And the side of AC equal to the square root of 25 also. So when you have a triangle, obviously you have two sides that are the same length. That was a horrible triangle, but it's true. So this side and this side are going to be the same length, and one side is going to be a little bit longer. So that's why you'd probably say in the triangle that we drew that these two sides here, these two sides here, I don't know why I just circled that, but those are going to be probably 25, and this side down here will be 50. And that's why it proves that it's an isosceles triangle, because it has two parallel sides, because this side and this side are parallel to each other. You can also put the little dashes if you want to show they're parallel. So, yeah, and then this side is not. But yeah, that's how you solve it, and that's how you prove that it is an isosceles triangle, because it has two pairs of parallel sides.